A presentation about HTTP2. It is a new protocol for the web. New is relative. It's been out for a couple of years, but it's only recently got traction and effectively been used. Google has been a great promoter of this, as you'll see throughout the slides as well. What am I going to talk about? I'm just going to see if I can handle the resolution. First, I'm going to tell you what the current, well, I should now say old, version of the internet is. It's called a protocol called HTTP 1.1. Then I'll tell you how HTTP works, because you need to understand the inner workings before you understand the improvements HTTP2 can bring. What does HTTP do? HTTP2 do? What are the benefits and why would you use one over the other? There are some disadvantages as well. It's not all fun. I'll highlight those as well. And then we'll do some small performance comparisons to see if and how it actually makes an improvement. And we'll conclude a few things as well. First of all, who am I? My name is Mattias. I'm a system engineer and a support lead at Nucleus. We do hosting, we manage servers that run your Drupal applications. So my point of view is mostly server-side, where your point of view will be code or front-end mostly, I think. I used to be a PHP developer, back when PHP 4 was really cool, so that's old. I mostly do operations now, so I live at the command line on a Linux machine. And I strongly believe in the works of DevOps, and I will promote it wherever I can. I'm also a blogger at that URL, and if this talk is interesting to you, you can go to that URL/HTTP2. You can find a summary of the slides, a more write-down version of the content that I'm going to give you. This is an experiment. Last week I had the idea, hey, why don't I start a newsletter? I called it Cron.weekly. I haven't even sent a single newsletter yet. But if you're interested in Linux news, feel free to sign up. Now, a bit of history before we can get to the actual HTTP2 part. First, what is HTTP 1.1? It's a very simple client-server protocol. There's a client that requests something from the server generates something and gives it back. So it's an entire protocol that relies on requests and responses. If the request is valid, the response can be valid as well. It's been in existence since '97. If you do the math, that's almost 20 years. That's a long time for a protocol to be used on the internet that we use on a daily basis that hasn't really changed much, except for, well, HTTP2 that's now released. It uses a concept of metadata for requesting data. It's hidden in headers. You usually don't see it until you're debugging something cryptic, but that's part of the protocol that's built in. Without HTTP, there is no web. I think it's fair to say that. Sure, there's a network, but not the web that we're using today. And it's a very simple protocol, as I mentioned. It's plain text, which means it's very simple to read, but it's hard to parse. If you've ever had the joy of implementing some kind of plain text protocol, you'll usually find that whoever uses the protocol tries to hack around the limitations of plain text, and that's where it gets interesting to parse the context. Now, that's the idea of a request header to be sent in this protocol. For example, if you as a user would like to browse a website, you'll open your browser, which is called a user agent, and you'll type in the URL at the top. What actually happens behind the scenes, and what you usually don't see, is that there's a TCP connection being initiated to that endpoint, to whichever DNS is behind that URL on the default port 80. TCP means there's a lot of things going on in the background. You've got a three-way handshake, you've got a TCP congestion window, all those things that you don't really see in the browser, but that are fundamentally slower parts of the network that you're using. Once you've established that TCP connection, then your client, your user agent, can send an additional request. It can start to send headers. Headers are what you as a user or a user agent, your browser, can do to describe what the content is that you would like to receive back. What does that look like? Before I go into these, has anyone ever looked at the headers in the browser? Show some hands, wake up. Okay, most of you, great. You'll recognize all of these. First, to start, at the moment your TCP connection has actually been established, you'll say, what's the URL that I'm trying to achieve and what's the protocol that I, as a user, understand? Next is a header that will tell you what kind of content that you will accept. You can say, especially if you're doing some kind of RESTful APIs, I accept a JSON response, or I accept an XML response. If you put it like this, it's just whatever you have, send it to me and I'll figure out how to handle it. You can, of course, compress your content. As a user agent, you can tell the server, I understand gzip or deflate. Those are two mechanisms to compress content. Either one of those is great, just send me whichever you have available. You'll tell whichever host that you're connected to, that's the DNS part and the TCP stuff that we saw earlier, what the actual site is that you're trying to load. Now, this can be anything. In fact, if you were to connect to any server and request localhost, that may very well be a valid website that you can retrieve back. So that the entire idea of having a name in your browser and the name that does or does not correspond to a website, that's just handled by the host header that you send on every request. And then you'll say who you are. Of course, this is just a piece of plain text. You can say whichever you want. Most browsers are honest, and they'll say that they're an Internet Explorer, they are Chrome, they are Firefox. There are a lot of websites that filter content based on the user agent that they get. And a very big one is some kind of exchange website that if you were to announce yourself as being Googlebot, you suddenly had all the content without having to subscribe, so that Google could index, but a Firefox or Chrome user would not be able to get the content. Very simple tricks to just fool the internet. And there are very simple key value pairs. Now this is easy to write, and this is rather easy to parse. You have your key, semicolon, and a value. But you can put pretty much anything in that. There's no limit to either the key or the value. And that's where it gets interesting. Now, as a user agent, the moment that you enter a double new line, so you've been giving a header after header after header, if that's a new line and you add another new line, that indicates your request is done. The server will end receiving your input and start validating whatever it was that you requested. What does that look like? In essence, there are three big parts of the HTTP protocol. One, there's this thing that you don't really see every day. There's the TCP connection. It's hard to visualize as well. Compare it with using a telnet at the command line to connect to a host. This does the three-way handshake, the TCP congestion, all the things behind the scenes. Then you give your headers, end with 2 new lines, and the server gives you a response. Now, that response, and this is where it gets more interesting towards HTTP2 as well. What does your response mean? For example, the user requested some kind of URL, you've sent all your headers to describe the content that you want or can receive. The server is busy generating all its PHP, all its MySQL, it's calling out third-party APIs. It gets its content and it sends back HTTP headers and data. The headers are the metadata to describe your request, and then just your blob of data to be passed along. For instance, it will start by saying either an HTTP 1.1 200 status code, meaning everything was okay, whatever you sent to me, I understood it, here's my reply to you. The most other common user codes you'll see are, of course, 404, 500s, if some kind of Drupal error occurred. It can also say what kind of cache control it has, just to indicate that the server was busy generating a response. Maybe it would like the client to hold on to it a bit longer than the client would like. Just so the server at the next request does not have to be generated all again. Now, we had an accept encoding header that said, I would like a response to be either gzip, deflate, or just plain text. Server interpreted this as, okay, I can make you a gzip response. The content that's about to come to you, this is the content encoding. So whatever you had now, in fact, if you were to see this entire request, whatever comes next would be gibberish. It's the gzip encoding version of your HTML. And it will tell you how long the content is, so that whenever the server stops sending, the client can validate, okay, I've had enough bytes, I'm ready, I can now decrypt and start serving the content. It will also tell you what kind of type it is, text HTML, XML, JSON, just to make things easier to interpret as a user agent. And in some cases, it will tell the server that was used to generate the request. Not exactly useful, just from a debugging point of view, it's nice to have. In fact, most don't just say Apache, but say Apache with an entire version number, which reveals a bit too much information for your server. If you're a bad guy, it can be used to find hacks or anything specific to that version. And it will give you a date. The date is mostly used in comparison with the cache control header. So the server thinks this is the time it got generated, and it should be cached for 3 minutes or seconds. I'm doubting now. But the client that gets the request will use this date to use the date to validate those 3 seconds or 3 minutes, whichever it may be. So they're the same kind of key value pairs. Oh, the other way around. Still readable? Sure. Okay. What does this look like at the command line? So we'll skip the request headers. You're making an HTTP request, and this is using the HTTP client. Most examples use curl, which is an awesome tool, but the default syntax and color highlighting that HTTP has is pretty useful in demos as well. So we'll request something, we'll get a response back with exactly the same headers we saw earlier. Then the double new line and the HTML, the content that we actually requested. That's the HTTP protocol. Request, response, done. Now, HTTP 2. What does this add that HTTP 1.1 lacked? Or what problem are we trying to solve that is hurting us at the moment? Zooming is very hard. First of all, it's a binary stream, no more plain text. What does this mean? At the moment, you can telnet to any server from the command line, type your headers, hit enter, and get the response. That will be, depending on how smart you are, either impractical or impossible to do in a binary protocol. Well, the moment you start a TCP connection, so the moment you telnet to some host on port 80, from then on, you should be speaking binary and no longer plain text. It is based on Google's Speedy protocol. This is something that Google has been using for a little over 5 years, I think. Speedy, the protocol, has been discontinued and is entirely HTTP 2 at the moment. This is a fancy term. HTTP 2 is using multiplexed connections. It uses, instead of multiple TCP connections to a server, it will use one master connection and just pipe everything through that one connection. This will become apparent in the next examples, what the benefits and downsides of that system are. HTTP 2 has a cool feature called server-side push. It works a bit like magic, but we'll get to that in one of the next slides as well. It's one of the, in theory, best parts of HTTP 2, although recent benchmarks have actually shown that when used in practice, it may not be as great as was advertised. And because of the multiplexed connections, since you have now one connection to a server where you can request a lot of content, you can use a system called priorities. You can say, okay, I want my website and my CSS and my JavaScript and my images, but I want to have my CSS first and my images later. I want that order to be maintained. Who supports HTTP 2? Because it's nice all in theory, but if you can't use it, what can you do with it? If you can read it, most of the major browsers today support it. We've got some older Android devices that are still lacking, which probably won't support it anytime soon. But if your users are either Firefox, Chrome, Safari, or a recent version of IE, you can use HTTP 2 without a problem. Client side is, of course, only half the story. You've got servers to run that content. What kind of web server do you need to support HTTP 2? You can use Apache with a small asterisk. Apache 2.4 is the only version today that supports it, which is relatively new, and about 90% of all the Apache servers out there are running 2.2. So in theory you can, in practice it's rather difficult to get that version running on a stable manner on your servers. Nginx supports it. Let me just zoom out again. As of, I think about a month, it's been publicly available for Nginx. So if you're now running Nginx on your systems, you can, with a few simple commands, enable HTTP 2. And then you're actually done. You no longer need to do anything new. So to activate, it's a really simple tool. If you want, the slides will be up later. There's a link here to how you can enable that in Nginx. And if you're on the Microsoft side, which I doubt many of you will be here, IIS 10 will have HTTP2 support, except that it's only in Server 2016, which is a technology preview release. It's not generally available. So seeing as you're all Drupal and PHP and open source, my best guess would be most of you are running one of those above, and you have methods of running HTTP2. There are alternatives that have been rising more and more. Because of Apache and Nginx taking their time to implement HTTP2, others saw the opportunity to jump in. We've already had this market where Apache and Nginx have been sort of the boss on the open source web server side. H2O and HTTP2 have both been very active recently, have been the first production-ready web servers to implement the new protocol. And in many cases, they are used as a proxy before your Apache or your Nginx. So you usually had a setup where Nginx was the first to get your request, and then it would proxy to Apache or something else. These are even more proxies to put in front of your proxy, just to support HTTP2. Now, since about a month, both Apache and Nginx have had proper support. I'm not sure what that will do to either H2O or the other one. Maybe they'll die, maybe they'll live on. If I had to venture a guess, stick to Apache or Nginx. There is something else below. Bottom line right now, it is getting easier to support HTTP2. It has been hard because you have to self-compile everything, which leads to a scenario where most of the things no longer get updated. It's getting easier, but we're not there yet. In about 6 months, I think we'll have an entirely different conversation. What are those actual benefits of HTTP2? Is it faster? If so, how much faster? Does it use less resources? Because that would be nice, just a fun thing to have. How does it handle its bandwidth? Should we see an increase, a decrease? Can we get more control of what happens on the server side, or is the client still the boss? Which, in today's case, the client is definitely the boss. The first actual benefit of that new protocol. It's a thing called domain sharding. We've been using it for 10 years or more, and it was a really cool idea to have more of your simultaneous concurrent sessions on a website. If you browse to CNN or anything, you'll probably load about 100, 200, 300 additional files on just your main request. A default browser will only open 6 connections per host. What does that mean? Gopher Tiles is a really cool demo site if you want to just test it out. I hear the Wi-Fi is great here, so just go for it. What this does is, it opens a website that has been configured to load 200 additional resources. Resources being JavaScript, CSS, images, doesn't matter. But what you can see in your browser is that a default browser will open to that same host 6 connections and download the first 6 files. As soon as the first of those 6 is done, it can start another one. And it will only, at one time, have 6 connections open per host. Now you can see where this becomes a problem if you're trying to load 100 or 200 additional assets, which isn't uncommon for web shops or anything like. So that's why we as developers or as sysadmins try to shard our data. What we try to do is, instead of just going to yourdomain.com/file1, file2, file3, we go to cdn1.mydomain, cdn2.mydomain. And all of that just pointed back to the same server, but it tricked your browser into opening multiple connections, because those might be different servers. The browser has no idea about it. And just request more files at once. It paid off. It really gave a more fluent idea of a website. It loaded faster, it was more responsive. Now, since we've been sharding, our browser can open multiple connections. Everybody wins. But a few that seem small, but are pretty significant downsides occur at that moment. First of all, your browser needs to do multiple DNS lookups. A DNS lookup is seriously fast, but it still takes 50 to 100 milliseconds. That's up to 100 milliseconds that your browser is just blocking, waiting for a DNS. And then it has to start with a TCP connection to the remote server, which if you're familiar with more low-level TCP, it's a pretty complex process. It's sending packets, waiting for a response, validating the response, etc. And for some reason, TCP also has this idea of a slow start, that any new TCP connection that you starts off really slow. And it just gradually cranks up and cranks up and cranks up. It's just to find the bottleneck of the server, but clients are conservative in that matter and just try to take things slow. It's a bit like a first date. Now, despite those downsides, it was in most cases still beneficial to do this kind of domain sharding. How does HTTP2 fix this problem? First of all, we have no longer the notion of only 6 connections per host, because in this new protocol, we'll only have 1 connection at any time. And if you were to shard at this moment, you would actually be hurting the protocol, because you would be doing what HTTP1 was doing, which is just another DNS lookup and another TCP connection and another slow start. Whereas in HTTP2, that's no longer needed. You already have that 1 connection that can handle a lot of multiple requests at the same time. So multiplexing, and that's the biggest feature that HTTP2 offers. That's also the biggest change, because in order to multiplex, in order to have 1 connection and send multiple responses, it can no longer be plain text. Because in a plain text response, you don't know if your response was either the first, the second, or the third. With a binary multiplex protocol, you can have more metadata in your headers, the TCP headers in this case, that make that possible. And as an additional benefit, you can use priorities, but we'll get back to that later. Because of only having a single connection to transfer files back and forth, it maybe could mean the end of those entire concatenated big CSS of JavaScript files. Why? Because depending on your website, of course, all of this is depending on your website and the kind of traffic that you're serving. Why would you send a 150 kilobyte CSS file if that particular page that needs it only loads 5 kilobytes? Maybe those other 145 kilobytes are used on different pages. In HTTP1, that may have been a good idea. Just send it once, let the client cache it, so that for future requests we don't have to do the entire TCP dance. Now for HTTP2, because you only have 1 actual connection, why not only send the CSS that the client needs for that particular page? It could mean less data transfer, you no longer have the bottleneck of connections, etc. This is something that in theory is great. In practice, it just depends on your site. If you have a busy web shop, maybe it pays off. If you make your living blogging, maybe it doesn't. All circumstantial. A benefit, depending on how you look at it, is that in order for the new protocol to work for your clients, your site needs to be HTTPS. Now, the protocol of HTTP2 doesn't actually require HTTPS. There is a perfectly valid alternative with all the same benefits that does clear text only. But browser makers like Google Chrome, Firefox, etc. have all just said that that's a good idea for your protocol, but we will not do it that way. Whenever we want HTTP2, we will require an SSL connection. The alternative was H2C, which is the plain text version of HTTP2. But as I said, you won't find it in production anywhere at this moment. So if you want to offer HTTP2, you will have an SSL certificate, which means more fun managing them. If you make a mistake with your SSL certificate, your site's offline, your visitors will get pop-ups, etc. You will have a lot of fun having to handle with mixed content, but in the end, it pays off. If you want to read more about this, there's a really cool initiative called the Let's Encrypt initiative from the Electronic Frontier something that offers free SSL certificates. They are now in beta, they work. So if you're still paying more than a few $100 per SSL certificate, check those guys, it's free. And a little rant from myself about the pains of having to manage your SSL certificates and all the things that can go wrong. Another benefit of the new protocol is called compression, because the current version, if you send a request to your server and you give all your headers contain in plain text whether you support compression or not. That implicitly means that you can't actually compress your headers, because that info, that part of the protocol, needs to be understood by the server. You can't say, I understand gzip, but already encrypt your, compress your request in gzip, because the server won't know how to handle that. The new protocol solves that. You have a built-in method of compressing your headers. In the old world that never happened, and that actually caused for quite a bit of overhead. There are a lot of websites that send a ridiculous amount of cookies. Cookies are all headers. Headers are all plain text and are never compressed. And towards the end, they really start to add up to everything of the bandwidth and the traffic that you're generating. If you compress your headers, of course this is only for the headers, you can achieve a rather great compression ratio. Of course you're only sending headers, it's not like you're sending 10 megabytes of data. But for all the headers that you are sending, why not compress them? The standard that HTTP2 uses is called HPAC. HPAC is just their name for the HTTP compression. Just a small example, you can all read numbers. It comes down that in the old world versus the new HTTP2 world, you'll have about an 8-time reduction in size. Why not? Server-side push. This is one of those, in theory, excellent features of HTTP2 that we have yet to see in action. In the old world, you, the user agent, or in most cases your browser, would try to be smart and add its own kind of priorities to the request. If you load CNN.com, it will detect I need JavaScript, CSS, and a couple of images. But just to be sure, I'll send my CSS first, because who knows what kind of additional requests I need. So it's the user agent that determines what your priority is for sending that data. In the new world, the user agent would add priorities to a request, but the server can still deny that as well. It adds the additional benefit that as a server, you can even send data that your client has not even requested yet. This is magic. What does that mean? You're visiting CNN.com. You, as the webmaster of CNN.com, you know that anyone that visits your site will eventually have to load your main JavaScript or your main CSS file. What usually happens is your client requests it parses the entire DOM, and then it just goes out to fetch the CSS. With this system, your server can send the CSS straight away. I don't mean in the HTML, it just means as an additional request without even having the client request it. Of course, your client can deny it if it already has the file, etc. It's pretty smart about that. If you're thinking about, hey, these are WebSockets, not exactly, because you can't manipulate this. This is server-side only. What does that mean? Since I'm running out of time, I'll step up a bit. You do a request. Your browser parses the request and then figures out, oh, I need CSS. But that parsing time, that's actually additional time that we can avoid in this case. For instance, 50 milliseconds of just waiting for your browser to decide what the next request is. With server-side push, if you have a website, don't know if you can read it, but you can see the slides. If your website knows, okay, the next request is by sure a CSS file, I'll just go ahead and send it along. And that means request 1 ends, and just a millisecond later, the next file is already being downloaded. Those are 50 milliseconds or more that are just being saved right out of the box. Server-side push, it sounds awesome, but how do you as a developer manipulate this? How can you say, the next request is definitely going to be CSS, add that as well? That's where the standard gets vague. There isn't actually a real standard. Well, there's a standard for the protocol between your browser and the server, but there is no standard for your client or your PHP code talking to your web server to deliver it to your browser. What is definitely sure is that we will use some kind of header, meaning if you're in a PHP code, you can set additional headers. Your Apache or your Nginx will interpret this, and then use the HTTP2 protocol to connect to your user agent and send the data. Now, the part where your PHP code talks to your web server, that's unclear. We've got one server that already supports this, all the others don't. Neither does Nginx, by the way. And for now, they all use a link header. So if you, from your code, can say an additional link to this file, your web server, in this case ng-http2, would interpret that and already send it to your client without him requesting it. This is a bit unfortunate because the link header is already being used for other purposes. It's one of those things that WordPress builds greatly upon. Maybe this will change. Maybe every web server will get its own kind of header. That's unclear. So this is what I was saying earlier. Your client, your user agent, your browser goes to a web server, which then goes to your PHP code. Your PHP code can generate a header that will get sent to your web server, your Nginx, your Apache, and that will send the additional request to your client. We just don't know yet what that header will be. So this is an entirely theoretical conversation. So as I mentioned, we don't know yet the header yet. Priorities. As a user agent, as a browser, you can say, I want these 50 requests, and I would like CSS to be first, and I would like my JavaScript to be first, and then my images. This is a preference that you can have as a browser. You will not have a way to manipulate this. This is something that your Chrome will have or your Firefox will have built in. It can also be denied by the server. If the server gets a request and that says, I would like my CSS first, the server can say, that's not a good idea. I'll know better. Here's some JavaScript instead. Because your browser, because of the one TCP connection that we now have, as soon as the browser detects I need 50 more resources, it will fire all 50 at the same time. Another benefit of the new protocol, if you can call it a benefit, it's pretty much the same as the old protocol. You'll have the same status codes, the same response codes, the same methods, anything you like. So those codes that you remembered, still the same. Everything that you've done in PCR7, anything that you've done as a RESTful client, will also work on HTTP2. Just to sum up, if you implement the new protocol on your web server, you won't have to shard as much. You'll have to run TLS everywhere. You'll have free header compression with HBAC. You can have server-side push if that turns out to be a sufficiently great enough feature. You'll have something called request priorities that you cannot really influence, just it's there as an improvement. But there are some disadvantages. First, it's hard to run in production. Most web servers that have it announce it as a beta. Some web servers crash depending on the kind of request that's received. So it's still beta, keep that in mind. The protocol itself took large steps in some area and baby steps in others. Most critics say that it did not do enough. This was the time to completely redesign the way that we do HTTP, or the way we use our internet. But this is a hard thing to align with all the decision makers on the internet. So the protocol took baby steps. But these are the baby steps that we can use to add additional features. It took almost 20 years to get this version. I guarantee you that the next version will be here in 2 or 3 years. Now for the biggest problem, I think. If you're going to support the old and the new version for your clients, you're probably going to be in a bit of a problem. Problem is, of course, relative. What is good in the HTTP 1 world is bad in HTTP 2 and vice versa. Remember domain sharding. Great for HTTP 1, but serious overhead for the new protocol. And it's new. These are stats that I got a while back. 13% of all the requests that were recorded in Firefox were the new protocol. That's a pretty low number so far. Maybe you're bleeding edge, maybe you want to give it a go. Maybe you don't want to take the risk and just wait it out a bit. But just to conclude, performance comparison, that Gopher Tiles site that you should definitely check out. In the old way, it took almost 30 seconds to load this. Now this is a site with 200 additional resources per 6. In the new world, less than 2 seconds. Because the moment that you finish your first request, your browser can send all the additional ones and wait for the response without having to wait per 6 to get your actual response. This alone is worth it to implement. Few conclusions and then I'll wrap up. HTTP 2 is no silver bullet. It's a great protocol, but it will not solve your performance problems. If your site is now slow, it will also be slow in HTTP 2, because slowness is probably not defined in the protocol, but in the application. But if it's already fast, it will only get faster. Supporting it on your site or on your server is relatively easy, because you only need to enable it on the web server. Excluding things like server-side push, which would have to be implemented in your code, most of the protocol is just a single checkbox or a single configuration parameter away. And everyone that matters, all the browsers that matter, already have this kind of support built in. And what I already mentioned, supporting both protocols is going to be difficult. Not impossible, definitely not hurtful, just challenging. Because what's good for the other and vice versa is just bad for the counterpart. That is the end of my presentation. If anyone has any questions, and if I have time left, then I will gladly answer them. Yes?
Why did it take so long?
If this was designed 15 years ago, it would have been super easy. Today, the web is dominated by Google, by Mozilla, by a lot of companies that we don't even know about, and they all have different interests. The one company wants to make advertising as delicious as possible, the other wants to protect your privacy and enforce SSL. And those two don't really, they aren't good friends. They have mutual benefits. It's actually a miracle that this version got out, which is only because of Google's arrogance of just making its own speedy protocol, enabling that in its own Chrome browser, and just showing to the world, this works. Now follow our lead.
How the user client knows which protocol to ask, because he doesn't know the servers?
Correct. If you are a web browser and you connect to a server, you will add an additional header in that request, which says, hey server, if you understand HTTP2, so do I. Let's switch up. And that way the server can still say, okay, I understand that you speak a new protocol. Here's a new binary stream, let's talk binary from now on. But it's still, it all happens on the same ports, and your first request will always be the old protocol, just to determine if the new site supports it, yes or no. No more questions? Okay, thank you then.